Welcome to Chapter 8. In the previous chapter, we studied variables and different data types. Now we will study how we can apply different operations on these data types. Let's start. Operators are used to perform operations on variables and values. In the example below, we use the plus operator to add two values and display the result, as shown in figure 14. In cell 1 of figure 14, we add the values directly and display the result under print function. On the other hand, in cell 2, we first assign values to variables a and b, and then we add them using plus operator. First up are the tools you're probably already pretty familiar with, even if you don't realize it. These are the arithmetic operators. Arithmetic operators are used with numeric values to perform common mathematical operations. The arithmetic operators are provided in Table 2. I like to call them the calculators of your code. They're the workhorses that do all the heavy lifting when it comes to math. So you've got your usual suspects, right? Plus for addition, minus for subtraction, and that little asterisk which means multiplication. Then there's division, and you see that percent sign. That's for modulus, which is a super handy way of just getting the remainder after you divide two numbers. And here we can see one of these in the wild. Look at the plus operator doing its thing. First, it just works on numbers. 10 plus 5, well, that gives us 15. Easy enough. But, and this is the important part, look at the second example. It's working on variables. The computer goes, okay, what's in A, what's in B, and adds those values together to get 3. That flexibility is what makes them so incredibly useful. Alright, let's grab the next set of tools from our toolbox. These are the comparison operators. Comparison operators are used to compare two values or variables. The comparison operators are provided in Table 3. If the last set were calculators, think of these as a set of precision scales. Their job isn't to calculate a new number, but to weigh one value against another and tell us how they relate. Now, unlike our calculators that give us a number, these operators give us a much simpler answer. It's always one of two things, true or false. That's it. But pay close attention to that double equal sign. This is a classical example. A single equal sign is for assigning a value, but a double equal sign is for asking a question. But are these two things actually equal? Let's see how this works with a quick example. So let's say x is 10 and y is 5. We can ask the code, is x greater than y? The computer looks at it, does the comparison, and comes back with true. What if we ask, are they equal? It'll say false. Every single comparison, no matter how complicated, just boils down to a simple true or false. Okay, time for the most advanced tools in our basic kit. If comparisons and operators are the scales, then these guys, the logical operators, are definitely the brains of the whole operation. Logical operators are used to combine conditional statements. The examples of conditional operators are given in Table 4 as follows. They let our code take all those true-false answers we just talked about and combine them to make some really complex decisions. Here are the three main ones you'll see everywhere: and, or, and not. The and operator is really strict. It needs every single condition to be true for the whole thing to be true. Or is much more relaxed. It only needs one little piece to be true. And not, it's simple. It just flips the result. It turns a true into a false and a false into a true. Let's just walk through this one together. So let's pretend our variable x is the number 7. First, the code asks, is 7 less than 10? Yep, it is. So that part is true. Then it asks the second part, is 7 less than 5? No, it's not. So that part is false. Now, because we're using that very strict AND operator, we have one true and one false. That's not good enough for AND, so the entire statement becomes false. And that's it. That is literally how code makes a decision. So there you have it. Let's recap as summary. First, you've got your calculators, the arithmetic operators, for doing all the math. Then you've got your scales, the comparison operators, for weighing different values and getting back a true or a false. And finally, you have the brains, the logical operators for taking those truths and making smart choices. And it all just comes right back around to that core idea we started with. Every single one of these tools, it doesn't matter if it's a calculator, a scale, or the brains, they all exist for one reason: to perform an operation on your data. This is the engine that drives all of programming. So now you've got it. You have the fundamental toolkit. You get how code calculates, how it compares, and how it makes decisions. And this right here is where all the creativity really begins. The only question left is, what are you going to build with them? Thank you, and see you in the next chapter.